All right, legends, this is Mr. Mays joining you now through the beautiful digital space that we have available to us. And today we're looking at Unit 3 to 4 Pro Tips. This is going to be a useful one. I have no doubt that near the end of the year, this is one of the ones you will come back to a fair number of times as a prep measure, okay? And I'm going to tell you really quickly some intro things that you will not be surprised by, which are here's some things you should definitely review because you're hopefully coming to this right before the weekend or during the weekend to be sure that you're getting to everything, right? Here's our situation. 1, you should go through the Unit 3 exam. Make sure you know that inside out and backwards. Check that, Roni. 2, the Unit 4 mini quiz. Go through that, make sure it's clear, and of course, the review guide. And the Frappy. If you've gone through these 3/4 various things, you're already in pretty good stead, okay? And if you know them inside out and backwards, you will nail this test. There are only a couple of curveballs, and they're all within the realm of satisfied understanding, right? But those are our starting points. And I want to start out by telling you this. I have mapped out for you 14 different things for you to keep track of. 14 that I'm going to go through today. But before I do that, I just want to be very clear with you. This is a hard test and probability is difficult. But at every given point, you remember that you have practiced this inside out and backwards. You know it inside out and backwards. And as long as you know your rules steadfastly and you apply them sensibly, you can solve anything. Anything. Okay? So trial and error, be sensible, kill it. Okay, let's go in. Tip number 1. Know your translations, okay? And know your rules for translations. So remember always that for multiply and divide, that will work for the mean or the standard deviation. Both of those will be impacted by multiplying and dividing. On the other hand, adding and subtracting only applies to the mean, not standard deviation. We do not add or subtract from a standard deviation. Subpart of point 1 is just remember that some of the things that translations are things like the following. Going from ounces to dollars. That's one version, right? Another one that we've seen is going from degrees Fahrenheit to degrees Celsius. And be aware that, of course, the opposite would be true as well. Translations are when we take one variable and we change the metric by which we are measuring that specific variable. So we're not changing the distribution in any way, really. What we're actually changing is we're saying, hey, I'm going to turn this from this type of metric into this other metric. So know your translations. Part 2. Know how to find mean or expected value. Know that those are the same things. From an outcome distribution table. Right? So if I have my x, p of x's set up, and all of my values set and their various probabilities, know that you have to take your various outcomes. Let's say it's 0, 1, 2, and 3. And let's say they're all equivalent for the sake of argument. It's just 0.25, 0.25, 0.25, and 0.25. Obviously, these could be different probabilities. They probably will be. But know that in order to get your outcome distribution's mean or expected value, you will just do x1 times probability 1 plus x2 times probability 2, and so on and so forth, all the way until the end, and add those up, sum them, and that will give you your expected value. That's obvious to you, of course, but know how to do that, and know how to translate those values, which you can do by either changing each one of the x expected values and then running the calculation, or just running the calculation and then, of course, multiplying the mean. Forgive my nose, I'm having a bit of a cold. And then multiplying your mean by whatever the translating factor is, whether that's turning, again, ounces into money, degrees into a different kind of degree, any different kind of alteration that you make. Just know how to do that. Okay, number 3. We're rolling all. We're doing it. Adding and subtracting random variables. Know how to do it. Know how to do one mean minus another mean. And know how that looks. Know how to do one standard deviation minus another standard deviation. And know how that looks, right? Of course, for standard deviation, we will be adding the variances for each and then square rooting it. And then, of course, for the means, we will literally just subtract them as we would normally, and then know how to add them, of course. These are pretty easy, but it varies depending on what we do, know when those are going to happen, and know how to do those explicitly. Part 4. Rule 4, I should say. Remember how to transform a variance. Now, this shows up for the first time for you explicitly in the review guide, okay? Here's how we do it. Now, you should be able to figure this out given what we've done with standard deviation, but let's just go through it really quickly. If I give you a standard deviation, okay, and I want to be clear, I'm talking specifically about number 5 multiple choice on the review guide, okay? And the way that one works is, assume we take our sample and we do times 5 to that sample, and then we add 4 to that sample. And we have a starting variance of 2. And it says, what's our new variance? So we have to do the following for this problem. 1, we have to remember that 4, and you'll be saying this out loud too, does not matter because we don't add to our standard deviation or our variance. What we do instead is we do multiply. But we multiply because we're transforming or translating, however you want to put it. We do it to our standard deviation, not to our variance. So first we have to take 2 and take the square root of it, right? That gives us 1.4 about. It's like 1.41. Then we can multiply 1.41 by 5 because we want to do that translation, right? And that gives us another value. I'm going to check it. You should check it alongside me, okay? That gives me 7.05. Then, in order to go from this, which is a standard deviation, into a variance, I will square it once again. And what that will give me, of course, is 49.7, which is equivalent essentially to 50, which I think is the answer choice you're supposed to pick. Please forgive my nostrils. Ooh, there it is again. But be aware that that's how you transform a variance. And that should make logical sense. Frankly, I shouldn't really have to tell you how to do it because you should be able to figure that out given the rules for standard deviation, but there it is for you all the same. Let's move to part 5. This is 5 out of 14 tech tips. Oh, they're not tech tips. Thank God they're not tech tips, right? They are rules for distributions. Okay. Number 5, pro tip. Compounding random variables. Know how to compound random variables and when you are compounding variables. And adding, which is essentially the same, but compounding is when we have a distribution, right? A normally distributed situation with a mean and a standard deviation. For a thing, like an apple, we often do fruits and veggies for reasons unknown. And then I'm like, what about 6 apples? And of course, what we have to do is for the mean, it's easy. We just take the mean for 1 apple and we do it times 6. Checkaroo. But for the standard deviation, 6 apples. We have to do the variance of an apple, 1 apple, times 6, and then square root that sucker. Be aware of that. Be aware also of ones like the chocolates and roses problem. That's way back when. But also in the review guide, there's another problem that deals with, on the Frappy, there's a problem that has to do with chips, and that one deals with variance being used for standard deviation compounding. Know how to do that. Pro tip 6, I'm really going all in for you guys. I want to make sure you get as much practice as you can and you know all the ins and outs of your distribution and what it requires. So let's roll. Be able, and this should be obvious, to know the difference between if we're doing normal CDF, if we're doing binomial PDF, or binomial CDF, or if we're doing GeoMet, baby, GeoMet PDF, or GeoMet CDF. Those are your 3 big options, but you need to know when each one is useful. Here are my quick cheat codes. These are not hold fast always. There are other ways that you can tell, but got to be told it's approximately normal for us to be using normal CDF. It's a good sign that we're going to be using that on a particular question, and you know that. And remember that for normal CDF, the way we set it for our like greater than, less than, equal to, all that junk is we set our upper and we set our lower. That's how we kind of set our dimensions, right? On the other hand, binomial. Something like random is very important for binomial, right? Or it should be clear to some degree that they are clearly independent. And that is true, of course, for geometric as well. But the thing that is specific to binomial is n, total trials. You need some total number of trials n. And then, of course, something you need, again, for both binomial and geometric is a probability that is consistent. Consistent. Look at me saying consistent. We need a consistent probability. It cannot be a changing or wavering probability. Very important to know that that makes a variable a binomial variable, or a geometric variable for that matter. Consistent probabilities for our success rates and for our situation or odds of success. Okay, and then the little add-in for geometric, of course, is that we normally get questions for geometric that are like, how many until success, which is normally where I'm looking for a mean, right? Or we say, what are the odds that you get successful for the first time on the 5th try? These are the kinds of phrasing we should expect from geometric, right? And know when to do PDF versus CDF, and know how to do like equals to, greater than, less than, greater than or equal to, or less than or equal to. All that practice, you know what I'm talking about. Just know that stuff inside out and backwards, know what you're doing. Number 7. Understand the mean of x, right, or the expected value of x, and the standard deviation in context. That means know the sentences from like 4.1, 4.2, where we're like, tried this many, many, many times, you would expect to get a value of blah, or we would expect it to happen this percent of the time, or this probability of time. And remember, for standard deviation, it's like typical value lies, whatever your standard deviation is, units away from the mean. Right? And know how to interpret those and prepare those. Nothing too crazy. Number 8. If you take a look at the FRQ 2, Part A, where it says to define a variable, look at that answer and know how to answer that sort of thing. And the way that it answers it in my answer key is like x is equal to, and it says like the number of, and it dictates what that variable is, number of, dot, 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 dot. And it just sets it up, blah, blah, blah. And then it says it is distributed, and then you will say it's distributed binomially, or it is distributed normally, or it is distributed geometrically. And if you do binomially, remember that you would do B, and then you would do n number of trials and the probability. If it's normal, remember our notation is n, and then it's mean, comma, standard deviation. And for geometric, you don't really have to do anything. You can just say what your p-value is, right? Your probability value, I should say. Okay, so study that one. Make sure it makes sense inside out and backwards. Let's do number 9. This is a pushback. This is for Unit 3 stuff. Know your probability of A union B rule. Know your probability of A and B rule. Okay, specifically in relevance to independence. Right? So know that when probability of A and B is independent, it's just equal to probability of A times probability of B. But if it's not independent, then it has to be given to you, right? Remember that probability of A union B is equal to probability of A plus probability of B minus the intersection probability of A intersection B. And know that like union equations are pretty likely to show up, I'm going to give you some kind of union equation where I give you the probability of blank or blank happening, which remember is a union. And I'm going to be like, here's the probability of blank A and blank B. What's the probability of blank and blank happening? But it's not going to say it's independent. Okay, so you're going to say, well, it's not given to me, but you're going to look at your union equation and be like, that's going to help me solve it. So just know how to use these. These formulas, by the way, are provided on the test. Your independence formulas are not, but know those. And your two independence formulas, of course, are it is independent if probability of A and B equals probability of A times probability of B, just like I wrote a second ago. That proves it's independent. Or probability of A given B equaling probability of A normally would mean it's independent, right? Because B's probability didn't change anything. Excuse me. Okay, now we're on to number 10. We're going to use, let's go to purple for number 10. I should be a singer. Okay, number 10, this one's an easy one. Two-way tables. Practice with them. They're often the easiest, but know them. Appreciate them. Know how to read them. Know how to use them. Okay, and know your givens. Remember that with two-way tables, if it says given that blah, then that's going to be the thing that dictates your total versus if it just says in all, that'll be your total. Number 11. My tip number 11. Remember this binomial notation? I brought this up in class. There's this weird way that we like to notate binomial notation stuff. And that's by stating the number of trials, N, K. And then it'll be like probability of failure to a particular number times probability of success to a particular number power. And these two numbers add to equal your total value N, right? Where you go through those trials. They may put probability of success first and probability of failure second. It doesn't matter. Just know that this is specifically for binomial notation because it lets us know what the total number N of trials is that we are going for. Okay. Pro tip number 12. For geometric or binomial, be always ready to solve for an initial P. I can't give too much detail because this is part of my trick questions area, but for geometric specifically, or binomial specifically, distributions, there will be situations where I don't outright give you your probability value, but I give you the information needed to figure out that probability. Like you're looking to grab a heart out of a deck of cards, and you would know, for example, that there are 13 hearts out of 52 cards, and you would use that as your probability. Or I'll give you a bunch of different things, like there are 2 blue socks and 2 red socks and 5 green socks. What are the odds of a blue sock or a green sock or a red sock or whatever it is? So know how to do that. Know how to find a probability that hasn't been given to you that you have to determine from just raw numbers, raw data to find the probability. This is like the color of Harold's purple crayon from Harold and the Purple Crayon. Guys, there are only 2 more Unit 3-4 pro tips left. Number 13, second to last. Remember that when I say interpret, and these are the easier ones, interpret your mean or your standard deviation, what I'm saying is solve each, then write sentences explaining them. In context. So this goes back to those sort of like 4.1, 4.2 stuff where you're like, this mean means if you did this many, many times, yada, yada, yada. Go back to those explanations and understand them. This is the second time I'm mentioning that, so make sure you're clear on that, okay? That's what the word interpret means, okay? Solve, and then write a sentence for each, if I ask you to interpret each, and make sure it's clear what they are in context. And finally, your final tip, number 14, okay? Review the tube of toothpaste problem. Can't remember what his name was. I'm actually not even going to tell you where it's found. I'm going to make you go searching through our class notes and our homeworks to see. But the tube of toothpaste problem, you will remember that one tube of toothpaste was 0.85 ounces. And it was a cool situation where we made our lower 0.85, because that would be him running out of toothpaste or using all of it. And the upper was 100,000, because it was like, what are the odds that up above our curve, he needs exponentially more toothpaste than a single toothpaste tube holds. And it was a great example of a problem where it was like some kid was at a camp exposure and he had a tube of toothpaste, and it was like, what are the odds that he runs out if he has a mean of this, standard deviation of that? Review that. There is an iterative, a different version of that question that you will definitely expect to see on my test. Know how to do that inside out and backwards, and go plumbing for it if you can't find it. Guys, if you can believe it, that's it. Those are our tips. 14 all the way down. You are going through. It is all about normal distributions, binomial distributions, and geometric distributions, understanding them in context, being able to mess with random variables in various ways. I believe in you, and I just want you to know, I know this is hard, I know this is dense, but I am here with you, and on that test, you will drink up all the information, and you will give me fabulous scores. And you will not forget it. You will bring this with you for the rest of your life. And I'm so thankful to have you as a student. So proud to be your teacher. And so elated that I get to see you guys blossom and grow as you learn the ins and outs of language. And that's what this is. Statistics is a language. And unlike other math classes where you kind of just memorize and apply, in statistics, different phrasings and ways of altering questions should all be translatable to you as things that you can solve with the tools you have. And that's what it is. Essentially, you're going to come in, you're going to dissect what I give you, and you're going to show me, hey, Mr. Mays, I know how to do this every single way it conceivably can be done. I'm proud of you. I'm thankful for you. And this is Mr. Mays signing off.